Have you ever wondered what you'd actually see if you fell into a neutron star? At first glance, that sounds like one of those abstract science fiction questions. But the more you think about it, the more you try to picture it, the weirder it becomes. Because the experience wouldn't just be deadly, it would be almost impossible to describe using everyday logic. You're not just falling into a strange object in space, you're plunging into one of the most extreme environments the universe has to offer. Where matter is crushed, light bends, time stretches, and the very rules of physics twist into something unrecognizable. So let's try to imagine the unimaginable. But before we fall in, what is a neutron star? Neutron stars are born in violence. When a massive star runs out of fuel, its core collapses in on itself, while the outer layers explode outward in a supernova. For stars with enough mass, this collapse continues until it forms a black hole. But if the star is just a bit less massive, somewhere around 10 to 25 times the mass of the Sun, what's left behind is a neutron star. Now, the term star might make you think of something big, hot, and glowing in the sky. But a neutron star isn't big. It's actually tiny. About 20 kilometers across, or roughly the size of a city. But here's the mind-bending part. That small ball contains more mass than the entire Sun. In fact, just a single teaspoon of neutron star material would weigh about 1 billion tons. That's not just heavy. That's gravity gone wild. As you begin your fall toward the neutron star, you might not notice anything unusual at first. But as you get closer, everything changes. The space around the neutron star isn't flat like we're used to. It's curved, bent by the star's immense gravity. And as light tries to escape from the surface, it gets bent too. This means that even before you reach the star, you'd start to see strange visual distortions. You might notice that the far side of the star, yes, the part that should be hidden, is visible around the edges. The entire object appears surrounded by a shimmering halo, caused by gravitational lensing. Light is bending around it, revealing angles you were never meant to see. You're looking at a warped, curved reality, like you're falling into a funhouse mirror designed by Einstein. And then there's time. As the gravity grows stronger, it starts to affect the very fabric of time. If someone were watching you fall from a distance, they'd see you slow down. To them, your fall would take longer and longer, until eventually you'd appear frozen in midair, just above the surface. But from your perspective, time feels normal. In fact, it feels like everything around you is speeding up. The distant universe accelerates. Stars seem to rush through their lifespans. Galaxies turn faster. You are falling deeper into time itself. Now let's talk about radiation. Neutron stars aren't just dense. Many of them are also spinning, some incredibly fast, rotating hundreds of times per second, and some are magnetars with magnetic fields a quadrillion times stronger than Earth's. That's enough to mess with chemistry, biology, even the structure of atoms. As you fall closer, the invisible becomes deadly. You're bombarded with X-rays, gamma rays, and high-energy particles. Your hypothetical protective shell starts glowing, overloaded with energy. If you weren't shielded, your DNA would be torn apart instantly. Your atoms would stretch. Your electrons might even be ripped away, your body unzipping at the quantum level. And yet, you fall. As you close the distance, something horrifying begins to happen. The gravity is so intense that the force pulling on your feet is significantly stronger than the force on your head. This creates what's called a tidal force, and the result is spaghettification. You begin to stretch out. Your body elongates into a thin strand of atoms, pulled tighter and tighter. It's not just gruesome, it's inevitable. But here's the strange part. You can still see the surface. You're not falling into a black hole, where the event horizon swallows light and prevents you from seeing anything. Neutron stars don't hide behind a boundary. Their surface is there, and it's real. And it's alien. As you approach, the crust of the neutron star comes into terrifying focus. It's not molten rock or gas. It's nuclear matter. Solid, crystalline, and unimaginably strong. This is the densest form of matter in the observable universe outside of a black hole. It's so dense that even the strongest materials on Earth, diamond, graphene, carbon nanotubes, would crumple like wet paper under its pressure. The mountains on a neutron star, if you can call them that, are only a few millimeters high, but they contain more mass than Mount Everest. You're looking at a landscape made of crushed atomic nuclei, fused together under pressures that defy imagination. And then feel like an impact. You don't splatter. You don't explode. You just vanish. The atoms in your body are forced into one another. Electrons are crushed into protons, creating neutrons. And you become part of the star. A blur of quantum particles absorbed into an impossibly dense mass. In that moment, the distinction between you and the neutron star disappears. So what would you see? You'd see the universe unraveling around you. You'd see gravity bending the very light in your eyes. You'd see time twisting, bodies stretching, atoms disassembling. You'd see the most extreme physics in action, right up until the moment you no longer exist as a person, or even as matter as you know it. And then, nothing. No sound, no light, no awareness. Just compression, beyond comprehension. Neutron stars are like cosmic tombstones, remnants of dead stars, so dense and so strange, they defy everything we know about reality. And there are billions of them out there drifting silently through space. Invisible. Waiting. Watching. The universe is full of monsters, and neutron stars are among the scariest. Thanks for watching. If this blew your mind, don't forget to like, subscribe, and leave a comment with the next cosmic mystery you'd like us to explore. Until next time, stay curious and don't fall into any stars.